want to remind everybody about CES coming up in January, and we're celebrating the Women to Watch. And that is my perfect segue into our spotlight speaker for today, because Jess is here to share with us about Nixie and the Rainmaker, which is an exciting thing. And she also was a 2018 Women to Watch winner. So Jess, thank you so much for joining us today.
Woohoo!
Yeah.
Thank you guys. I love speaking to this group because this is the real grassroots group in the industry. This has been around. This has been around since what, 2017, I think. So basically, it's so nice to see a lot of the same faces, lots of new people in the group. But it's always been a group that really had a ton of talent in it. There's so few, not that Women in Drones has plenty of men who are involved in listening to the show, just because it's such a fantastic, series. But the women in this industry, there's not many of them, but when they are in the industry, they're pretty badass. I would say, in terms of percentage wise, the women are incredibly impressive in this particular segment. So anyway, thank you, and hi to everybody.
Awesome. All right, so Jess, we see you're in the car, and so I know you're traveling, and so if you want, just tell me when you want to share your presentation. I can boot that up and then share with us a little bit about you and your company and getting started.
Sure. You know what? Why don't you roll the slides, and it's going to be casual. You guys ask questions when you want, or we can leave it at the end, whenever something inspires you. But yeah, start rolling it. Thank you. So as you can see, ensuring clean water requires constant water sampling and testing. So what's really interesting about water is not confined to the water industry. It affects many industries out there, and this includes mining and shipping and oil and gas, of course, public utilities, but also beverages and pharmaceuticals. And also, when we think of lithium batteries, mining for lithium. So one of the processes to mine for lithium and other valuable minerals is you have to let the minerals basically sit in water for a long time, and you need to constantly water sample to know when you can pull out the lithium at the appropriate time. So we could go to the next slide. I'm going to kind of just banter on a little bit. So did you go to the next slide? Sorry, it's not showing on my side.
Okay, I scrolled up. So Bounce, can you give me
there we
thumbs
go.
up
Current water sampling analysis system.
What's that?
Can you give me a thumbs up if you can see it okay?
Yeah, I can see it.
I could see current water sampling and analysis systems. That's where you are, right? So basically the way that water sampling is done now is real old school. It hasn't changed. What happens is that people go out in the field with their boots, and they manually collect them. Like, as you can see, the two people in the water here, and actually on the right-hand side is the head of the water sampling division for the New York City Department of Environmental Protection. And they're picking up samples one by one and putting them in the cooler. You do this in places where you can't have a boat. Maybe it's too shallow. So alternatively, you get on boats and you have a boat crew, you have a captain, you have the deckhand, you have the sampling team. And the other portion is, besides for it being like labor heavy and equipment heavy, it's when you take the physical sample of water. Now there's sometimes, and I'm going to talk about the differences between using sensors to collect data as opposed to collecting the physical sample of water. Sometimes you have to collect the physical sample of water for sometimes governments require it because that's what they're used to. Sometimes that's the only way to look for a particular type of parameter, like heavy metals. And then you have to put the sample in a cooler, and you have to bring a cooler to the testing lab. And then you have to wait 1 to 5 days to get the results. And this is the process all over the place, all around the world, from New York City to India to Africa to Europe. Next slide, please. All right, so basically a couple of years ago, I designed this pink thing. It's more than just a pretty thing. It's fly free and sample anywhere. And this is an attachment to drones. We made it adaptable for the M600 and the M300 DJI, of course. It is tech agnostic. We can make it for any type of drone as long as the drone can handle the payload weight of the sample and the current of the water. People forget about that, but sometimes you got to think about the current, and it comes with an app. So basically, one of the cool things about this is now when you do a manual water sampling, you look at your watch, you write on a piece of paper, on a sticker, you put the sticker on the bottle. And if there's a problem with, if you make a mistake on the time, on the date, things get smeared, etc. Anyway, with drones, of course, you have telemetry. So you're able to simply take a photo when you're sampling, and then you know the time, date, location of the sample when you're doing the physical sample. When you are using the sensor system, that's a little bit more sophisticated. And I'll speak about that in a moment. Next slide, please. So this is what it looks like on the M600, water sampling at warp speed. Basically putting it on a drone. We use EPA approved sterile water sampling bottles. You can get them from any scientific equipment supplier in the United States and abroad. Very standard. We can also make Nixie. We modified Nixie to use 500 milliliter water sampling bottles or 250 for the M300. But we could modify Nixie, the sampling container, to be any size, basically. And they always have to be sterile. Of course, when you take a sample, you can't touch the inside of the bottle. You have to be very careful not to contaminate it. But anyway, putting it on a drone, you solve a lot of problems. You have a chain of custody. You solve the chain of custody. You always know time, place, location. Now, instead of the water sampling bottle, we're able to mount sensors on it as well. And the sensors that we use can collect up to 21 different water parameters. And this includes coliforms and bacteria, after heavy rains, after hurricanes, this is an issue. One of the big things to test, of course, it can pick up salinity. It can pick up, the water sampling containers can pick up lead, PFAS. This is a big growing problem in the United States. So basically, which is a carcinogen. So basically, if you look on the website, you can see the list of 20. I think we have 21 different parameters right now, and it's growing. As sensors develop faster, as they start getting proven out a little bit more, that's when we could start adding them on. But 21 is what is reliable right now. Next slide, please. And, the nice thing about this system, so you have the water sampling attachment, which is the sampling tool. And the second part are the mounted water sensors. And we use particular water sensors from Proteus Instruments and RS Hydro. But really we could use like any type of, there's like 7 different manufacturers that we could be using. The cool thing about the platform is that it automatically collects the data via Wi-Fi. And so this means that if you have a sensor version of Nixie, just simply dipping, it takes 1 to 2 seconds to dip in the water and collect the data. So you could have a sensor again in Colombia, in California, in Kathmandu, And all of that data is going into the app. So we're going to be collecting mass amounts of water data beyond geographic and geopolitical boundaries, which is really important because right now there really is not a centralized water database in the world. And this is very important since water is literally fluid. So what is happening in one country is affecting another country. And yes, I believe the Florida DEP will be using this. I saw that comment pop up. The ultimate product really is the data. Once we collect enough data, then we could start doing some really cool things with predictive analysis, understanding flows of certain materials, and just so everyone knows, when you're collecting water data for your entity, whether that's for a private company or a government agency, a nice thing will automatically let you know if something is exceeding the allowable threshold in that particular place. If a particular material is exceeding a threshold, it can alert just that team who's collecting it. It won't the data won't go out to everybody, only that team. And that means that immediately they can go on site and try to investigate what the problem is and see if the particular contamination source is coming from a singular area. And I'm thinking, for instance, of scenarios in the Midwest, especially like in the Ohio area, in Des Moines, Iowa. There's a huge problem with nitrates. So nitrates from fertilizers. So farms are one of the biggest polluters of water. The fertilizers run off into the waterways. So it's not only the PFAS, it's not only the lead from in that we saw in Flint, Michigan, and Newark, New Jersey, or the contaminations coming from the wildfires in California. It's also just farming. Next slide, please. Yeah, so in general, the factors are overwhelming the water sampling market in the entire world, including the United States, is simply population growth and industrialization. So, for instance, think about this. You see all of these people now and companies moving to Austin, Texas. They are going to get just their infrastructure is not going to be able to handle the amount of population that is moving to their city. And they're going to have to figure things out. And this is what's happening in a lot of different places. People are moving to more urban areas, and the old infrastructure is simply not able to handle it. Of course, the next thing is you have climate change, and we've all, I feel like I don't have to really speak about that much. We all see what's happening. And because of this, we're going to see, and what's happening is increased water regulations, because first of all, there's places in the world that water is literally killing people. And you see that in Africa. And then there's places that you suspect that people are getting sick from. And then there's places that we know that we get alerts every now and then. We get boil water alerts, and we know that water's going to be a bigger problem in the future. And we see places in the United States that have already run out of water. We see places in the United States that are now having water shipped in, and governments are paying for. But it's very possible in some places in the world this is happening, where beverage companies are buying up the water sources and now selling back clean water to the populations. Next slide, please. So we could kind of like go through pretty quickly these slides. I might be taking a little long to render on my screen, but we're talking about like blue-green algae. Can you go to the next slide, please? So what's happening is climate change and nitrates, fertilizers, are heating up our waters, which is increasing the algae blooms, which is toxic. So this is becoming a very big problem in the world, the United States. Agriculture with the nitrates again. Next slide, please. So we have to figure out how to balance everything because our ecosystem's completely out of whack right now. Like lead and other heavy metals. Okay, we've seen this problem in Flint, Michigan, as I mentioned, in Newark, New Jersey, and plenty of other places. Any place with old pipes that have not been replaced, very expensive to replace them. Next slide, please. This is what I was speaking about. PFAS. PFAS is a carcinogen. It's found in fire retardants, and you could see the blue dots where PFAS was found in drinking water, and you could also see the purple dots are military bases. So this is considered a forever chemical. There's no way that we have not figured out yet how to get PFAS out of the water. This is an issue that a lot of folks are working on right now, including the EPA in the United States. Next slide, please. Combined sewer overflow. So old cities such as New York City has a singular sewer system. That means that the sewage and the rainwater goes into the same sewer pipe. In newer cities, you have two pipes. So you have one that the stormwater goes into one pipe and sewage goes in another. That's better. This is not good, the combined sewers, because every time we have a storm event with a lot of rain, it overflows the sewer systems and it overflows into our waterways. So this is just a problem in a lot of places in the world with a singular combined sewer overflow system. Fecal matter. I mean, as gross as you can get. That's something that that New York City and many other places are constantly combating. Next slide, please. So basically, after hurricanes, you see a lot of issues with bacteria and fecal matter. So one thing that the EPA and a lot of different larger municipalities are testing right now, and this is fascinating, is basically DNA testing in water, right? But it's really pathogen testing. They're finding that they are able to track the rate of infection of COVID through testing the fecal matter in the water. And this is a very, very interesting new way to track diseases. I mean, prior you could track certain things in water, but it's just interesting with COVID and now emerging diseases. Next slide, please. Climate change. You could go to the next slide. I don't think I have to. I think everyone's very well aware of how climate change is throwing everything off. Oil and gas. All right. So in oil, I think this slide and the next slide, shipping, oil and gas. Basically, you have spills all the time. We've seen this in California recently, but also you have a lot of in shipping. You have a lot of illegal dumping off of the boats. And under, again, the Clean Water Act, the United States and other countries have similar ones, although not necessarily as strict, is the oil and gas companies have to do water sampling to prove that when there's a problem, what the problem is. They have to document it. It's something they all have to do. And this is one of the industries that we're targeting. It'd be wonderful to be able to target the government and governments first, like the public utilities. But because of the slow pace of government, sometimes it's hard to build a business off of. So we are targeting the oil and gas and the mining industries and shipping first. And we're hoping that the government entities, it's a slow cycle of getting the RFPs out, but we're hoping that they'll follow. Next slide, please. Oh, can we get to the next slide? Sorry, maybe it's not updating on my side. Sorry, it's not changing on my side. Oh, there we go. Shipping. Yeah, you could go to the next one.
Okay, so we're on mining now.
Thank you. I see it now. So I spoke a little bit about lithium mining. So as we all know, we're going to be more reliant on lithium batteries for cars and for phones and everything, for drones, of course. And basically, there's a couple places in the world where there's a lot of lithium mining. There's two different types. One is mining the ore, and one is mining the brine. And basically, the lithium sits in pools of brine, very salty water, for a year, up to 2 years sometimes. There's a lot of brine pools going on in Chile and Argentina, also Australia and in China. And basically, you have to constantly water sample the brine pools in order to know when is the right time to extract the lithium from it. So this is a very interesting. And by the way, yeah, all of this mining pollutes the water. So I wouldn't exactly call it a green energy. Next slide, please. It's not updating on my side. I'm sorry. What's the next slide? There we go. So basically, this is just a little, you could just read through it very quickly. These are the major water pollutant categories that we are able to collect data for and test for, and the reasons why. And you can see that, it's affecting every single industry. And every single industry has to comply. It's mandated in the United States to comply with the Clean Water Act. But beyond that, other countries are having incredible problems. Asia's having a massive problem. Middle East, of course, is having a problem. South America, and Europe. So really, it's the whole world. Next slide, please. So in terms of speed, let's just speak about that for a second. So we did like a sample, a study, looking at the maximum amount of water samples that the New York City DEP was able to collect in one day, given their sampling team, typical sampling team size. And we found that somewhere between like 29 and like 32 samples were the amount. And in the same area, we were able to collect 120. Now, New York City collects samples very close together. They're really very much on top of things as much as they can be. But this means that basically we're able to collect this much more efficiently at a reduced labor team, because we just needed the drone pilot and one person to put in and take out the bottles. We just did the physical bottles, not the sensors. The sensors actually, we can even get a little bit further. So the point is, we're able to collect more samples in less amount of time for less money. We're going to have it all documented automatically. And the cool part is the next steps is for full automation. So imagine Nixie with a sensor being programmed just to dip, dip, dip down a river. So again, 1 to 2 seconds it takes to collect all the data from one site, and they can fly and dip again. And our next step is automating it. Now, so you can automate it for a reservoir, you can automate it for a river. It might not be the best solution when you're constantly sampling in different places, when you don't have a pre-planned locations or GPS points. But I think that will be able to be used in many of the cases. Next slide, please. Oh, that's it. So thanks, and I'm happy to answer any questions you guys have.
Jess, very interesting. We need to connect. We definitely need to connect. I have a solution that would be complementary to yours.
Okay.
So I sent you my info, and we definitely need to connect.
Okay, sounds great.
Yeah. Yeah.
Who are you? I'm sorry, I don't see
I'm
you.
sorry. My name is Bounce Genesee, USOG, and I sent you my info. My first name is actually spelled PHARNS. So Bounce might throw you off.
Oh, nice to meet
and
you.
where are you located?
New York.
Oh, okay.
Mm-hmm.
All right.
And the
I forgive you.
Catskills. And the Catskills, actually, at the moment.
Nice.
Yeah.
Nice. Yeah. We definitely have a product already that would complement what you're doing. So we definitely need to talk offline.
Okay, great. Sounds great. Oh yeah, the Salton Sea, Eric Eric, the Salton Sea, that's a very big deal right now. They're actually doing a lot of exploratory lithium mining, right? Well, they're hoping to do lithium mining. They're looking for lithium right now. The US has maybe 2% of lithium right now compared to the rest of the world. Yeah, so I don't see anyone, and I'm sorry, someone might have to ask the questions if there are any questions. I don't really see them.
All right. Well, Eric had just posted the one about the Salton Sea. There's so many potential use cases for this. It's just amazing. And like I said, when I saw that post that you had posted here, several months ago, I just went, oh, this is fantastic. And so backing up a little bit, Jess, can you share how you got involved with this? What made you get that spark of interest in the beginning?
So it's a little bit, many of us, listen, this industry did not exist when I was in college. So I had no idea I was going to be working in the drone industry. But as it turns out, I was in like the visual data realm. I was working for a financial, first of all, Wall Street Journal, and then I jumped to Bloomberg News, and we were doing a lot of financial work, looking at data, crunching data, trying to find the stories in the data, essentially. And I got hired then for a water engineering firm, the largest privately held water engineering firm in the United States, called Hazen and Sawyer. And I was hired to help them utilize their data in a more efficient manner. But basically, it also taught me a lot about water and the government contracting process, and just a lot of things I had no idea about. And I started Rainmaker. The Rainmaker was supposed to be a company originally that was bringing new advanced technologies, ways of doing things to the civil engineering and the engineering and the government space and engineering. And then it kind of pivoted more and more all the time to drone work. So we started doing a lot of inspections with drones. We did a lot of work for the Department of Environmental Protection, again, inspection and monitoring, using sensors to detect certain things. Then we started doing inspections for bridges, then for tunnels, then for just critical infrastructure. So water, critical infrastructure, everything. But I was at one of these jobs for the New York City DEP, and I was standing next to a deputy commissioner, and he was speaking to another engineer about how logistically complex and difficult it was to keep up with all of the water sampling mandates that New York City had to comply with. And it was just this monstrous task all the time. So, I turned to him and I said, Jim, if I invented something that's an attachment for a drone that was able to collect water samples very efficiently and quickly, would you be interested? And he was like, yeah, I'd be interested. So that's how it started. And then we started it, we filed patents on it. And then I pushed it to the side because we got busy on the Rainmaker side. And just so everyone is clear now and knows that we recently have broken off the company Rainmaker that does all the inspection work from Nixie as a separate company. But anyway, we started getting busy on the Rainmaker side. And then when COVID hit, almost all of our government contracts were put on pause, and I had nothing to do. So I decided to get back into Nixie and to further, continue developing it and actually making it happen. So now most of my energy, about 90% of my energy right now, is on Nixie and not on Rainmaker.
Wow, and what a value. Water is such a commodity. And so and if anybody has questions, go ahead and throw them into our chat real quick, because we do have like a few minutes for questions. But I wanted to ask you about that app. How awesome is that app you have? So did you create that, or did you have a team of people that created it to gather that essential information on the fly like that? Haha, it's amazing.
Yeah, it's actually it's not released yet. We're still working on it. It's a team, and not just me. But a lot of my background is in visual information. I don't know if anyone knows who Edward Tufte is, who in this group, but I'm a disciple of Edward Tufte. He's like a godfather of modern information design. So basically, like a user interface and things like this, how people see information, how to convey certain information. So I have a heavy hand in the app, but there's a team.
Awesome. Wow. Amazing. Amazing. And I love what you're doing. And we want to thank you. Did somebody unmic? Yeah. No. Okay. So I thank you so much. It's fantastic information. We love what you're doing, and you're making things better for our future, and you're using our awesome tech to do it, right?
Yeah, well, you listen, I mean, we developed this for the drone community, because I thought, what is a device that can increase revenue for our drone service colleagues? Like so I believe there's a whole new vertical out there, which is just water sampling. So I think that, what's going to happen, because this is what's happening right now, we're getting contacted from large firms that want to use it, but they don't have any experience in using drones. So we know that there's going to be some firms who are going to be, committed to maybe starting up a small drone program, but we think most of them are going to be reliant on third parties. So that's where we would help connect the third party to the larger corporations, so that they can become a partner for them.
Awesome. Awesome. Well, thank you for all of your efforts and everything you're doing. And I just love the whole system that you have in Nixie, and monitoring our water systems and everything. I know there's a lot happening here in San Diego that is being monitored and needs to be monitored as well. So with that, unless anybody has any questions, maybe, I know you're driving, so if you'd like, I will post your contact information if you want into the chat. And with that, we are going to segue to our breakout sessions. And so today's topic, which I thought was pretty cool, I was just kind of going back and forth with Kim, and I say, hey, I got one. Tell us in our breakout session how you know of a unique way that drones are being used for good, such as Nixie, right? It's perfect. That kind of wraps it up.